Hello and welcome back to Apt for You. In this particular video we are going to discuss a problem from arrays, and the problem statement basically says that we have been provided with a set of numbers in the array which is nothing but -1, 2, -3, 4, 5, 6, -7, 8 and 9, right? So this is the array of elements, and we can clearly see that it has got some negative numbers as well as some positive numbers, right? So the objective of the problem statement is that we have to move all the negative numbers towards one side and all the positive numbers towards one side. In the sense, the output should be something like, suppose one of the output can be -1, -3, -7. You can see the negative numbers are at one side followed by the positive numbers, which is nothing but 2, 4, 5, 6, 8 and 9, right? So the problem statement says that given an array which consists of some positive and negative numbers, the objective is to convert the array into this format wherein the negative numbers will precede the positive numbers. Now you can clearly see that here I have basically maintained the relative position of the elements. For example, you see -1 comes before -3 followed by -7. So this position is basically maintained. Similarly here 2 comes before 4, 5, 6, 8 and 9. So basically you can see the order remains the same. But as per this problem statement, we will give a release, right? We will just relax the constraint and we will say that the relative position is not mandatory, which means that you can have elements like -3, -1, -7. It is fine. That will also be accepted because negative numbers are together, followed by, suppose you have 2, 5, 4, 6, 9, 8, something like this. That is also accepted because the only objective is the negative numbers should be one side, the positive numbers should be other side. That is, the relative position of these elements is not mandatory to be preserved. You might change them. Fine. So given this particular problem statement, how can we solve this particular question? Now we will start with the not inefficient, but in a sense one of the basic solution. We will start with the basic solution and then we will see which is the efficient solution to solve this particular problem. So I hope the problem statement is clear. Negative numbers one side, positive numbers other side, and the relative position of elements may not be preserved. Fine. So having said that, let us first of all try to find out the basic solution to this particular problem. So one of the basic solution can be maintaining two arrays, right? So we can maintain two arrays, right? And we will traverse the array. As we will find the negative elements, we will push it into one array. Okay, this will be one of the array, and if we find positive elements, we will push it into another array. Fine. And then finally we will use both the arrays which has a positive elements and negative elements to fill the original array ARR, right? Let us see how this particular idea will work. So basically you can see we have a function main. It has received some array elements and we are passing the array and the size of the array to the function rearrange. So basically now we have to write the function rearrange. So the function rearrange has basically received an array and the number of elements in the array. Now what should we do? We should basically, first of all, assuming the basic approach, right? Basic approach was two array approach. We will be using external space to solve this particular problem. So what should be done? Basically, let me just increase the size of the screen. Right? So what to be done basically is, we will first of all declare two arrays. Let us suppose I am declaring a vector array, right? Vector int and suppose x, right? X. Similarly one more array, vector int, suppose I am declaring y. Now the basic solution will be traversal of the array. So integer I, suppose, so for I equal to 0, I less than n, I plus plus, what am I going to do? I am basically going to traverse the entire array, right? So here basically I'll be traversing the entire array. So the basic approach that I am following is, let me just rub the output right now. Fine. So I'll be traversing the array from here till here. And what will I check? If the element is negative, so I'll say if array of I is basically less than 0. What does it indicate? It indicates that the number is negative. So we will basically push it into the array x. So x dot push back array of I. Done. I hope this much is fine. So we push the negative elements in the array X, and else what we are going to do, we are going to push the non-negative elements into the array Y. So that will be basically Y dot pushback array of I, right? So basically this can be done. Fine. So we have pushed the negative elements in the array X and the positive elements in the array Y. Now what we can do now, since we have already filtered the elements, right? So basically, which means that now our array X will be looking like this. Array X will appear to be -1 because it has negative elements, -1, -3, -7, and array Y will appear as this: 2, 4, 5, 6, 8, and 9. Now what we can do, we can basically traverse the array X first, right? So for that particular reason, what we are going to do is basically, I'll be writing here for, so for, now what should be done? So basically we will say I is equal to 0, right? I less than X dot size, right? And I plus plus. So basically we are traversing the entire array X, and we will update the elements in the array. So array of, instead of I'll be writing small x, suppose small x plus plus, right, is equal to avoid confusion, suppose I'm writing array p plus plus, and I will be declaring initially comma p is equal to 0, right? So what is happening, array of p plus plus is basically going to be equal to x of I. Done. Similarly you will be going for array y also. So for I is equal to 0, I less than y, I plus plus, not y actually, I less than y dot size is vector, and I'll do I plus plus, and then again same thing, that is array of p plus plus is equal to y of I. Fine. So this will basically, what will it do is basically it will be helping me to modify the original array. So original array can now be modified as, you will see the first element of the array, because I'm just starting with p plus plus, so p equal to 0 first. So array of 0 will be equal to x of 0 first, means this. So -1, then we'll have -3, then we'll have -7, then we'll have 2, 4, 5, 6, 8, and 9, right? So the original array ARR will be modified to this after these two loops are executed, right? So yeah, what next? So we can basically, yeah, so we can basically now execute this particular code because our array has already been modified, and we will basically compile this. So what is the issue? I equal to 0, I less than x dot size, I plus plus. So okay, this is for, fine. Okay, so we can clearly see that the array element has been modified, wherein the negative elements are towards left and the positive elements are towards right. So this was very basic approach to solve this particular problem. Considering the time complexity, it is obviously taking order of n, but considering the space complexity, it is also taking order of n. Why? Because you see we are using extra space, wherein we are using two arrays x and array y, right? So we are using array x and array y, which actually depends upon the length of the original array, the number of elements in the array, right? So basically this is not that efficient approach. Can this be converted to order 1, means in terms of space? Can you solve this particular problem without taking extra space, right? So now that is for now, as per this particular problem, what we have considered is that relative ordering is not mandatory, right? Relative ordering is not necessary, means you may disturb it, you may disturb the relative position. For example, you can have 4, 5, 2, 6, 9, 8. That is possible, but the only concern is the negative number should be before and followed by positive numbers. So yes, if that is the case, then we can basically come up with a more efficient solution to this particular problem. Now what is the solution? Basically we will be using the partition technique of quick sort, right? So we shall understand that particular problem now. So let me just erase this particular code, whatever I have written so far. We will try to modify this function rearrange. Now what is the partition technique? Now you see, basically if we have this particular problem statement wherein we have the numbers -1, 2, -3, 4, 5, 6, -7, 8, and 9. So what can we do is basically, so these are the elements of the array, right? they are unsorted and basically mixed up, right? The negative numbers and the positive numbers are mixed up. Now if we consider the partitioning technique, what we will do is we will have a value I which will initially be pointing to -1, and we will try to traverse with the variable j from starting to till end, right? And what will we do, as soon as we come across a point where the value of j is basically pointing to a negative number, then we will increment I by 1 and do swapping. So how will it work basically? So basically this is a partitioning technique. So if we just focus on the code to solve this particular problem, then you can see that we will be writing basically let us declare a variable integer I which is pointing to -1 comma j which is pointing to 0, right? What we will do, we will start with for I equal to 0, or you can say not for, while j is basically less than n, which means that we are going to traverse the entire array from starting till end. And meanwhile what we are going to do, is we are going to check if the number is basically negative or not. So basically if array of j is less than 0, which means if the element is negative, then we will increment the position of I and perform swapping of array of I with array of j. So how will it work? Let us see. So like right now what has happened is basically I is pointing to -1, right? And now when j is equal to 0, it is pointing to -1. So I will basically be incoming here, I will be incremented to this position, and we will do the swapping, which means -1 will remain here only, right? And finally we will increment j. So j plus plus. Next time what will happen? Next time j will point to this particular variable, no longer here. J is pointing to 2, and if j is pointing to 2, what will happen? See, right now I is pointing to this, j is pointing to this. Fine. So j is a positive number. So if j is pointing to 2, which is positive, then it will not enter this loop, which means don't do anything, just do j plus plus. So again move next, which means j now points to -3. Now as soon as j points to -3, right now I is pointing to -1. So we know that as soon as j is pointing to a negative number, you say I plus plus, which means I will now come here and now perform the swap between these two. So if we perform the swap between these two, what will happen? -3 will come here, 2 will come here, right? So basically you can see -3 comes here, 2 comes here, done. And what will happen? J will be incremented. So j will basically now point to this particular point, 4. Again this is not negative, j plus plus, j comes here, non-negative, j plus plus, j comes here, non-negative, j plus plus comes here. As soon as j reaches -7, what happens? Again this is less than 0, this will be executed, come inside I plus plus, which means I will point to this 2, I is pointing to this 2, j is now pointing to -7. So basically what we will do, swap. So swapping in the sense 7 will come here and -7, sorry, -7 will come here and basically 2 will come here, right? 2 will come here. Now j plus plus, j comes here, j plus plus, j comes here, j less than n, right? True. Now next time j will come here and will terminate. So you can see now finally our array has been modified. What you can observe, we can observe that the relative position of 4 and 2 has been disturbed. Why? Because 2 was basically always before 4, but now you can see 2 is present after 4, right? But one objective has been satisfied, that is the negative number are preceding all the positive numbers, and this is what the problem had basically focused on. We were not concerned about the relative position, we were only focused on the condition that the negative numbers should precede the positive numbers, and we have successfully achieved them. Time complexity of this particular process was order of n, because we are just doing a traversal. Space complexity is obviously constant, because see, we haven't used any extra space, right? We haven't used any extra space. So we will come up with a new variation of this particular problem. So here in this particular problem we have used partitioning technique of the quick sort, and what has happened is basically the relative position is not necessary to preserve. That is why we were successfully able to implement this technique. But if they say that the relative position has to be preserved, means you cannot disturb the relative position, in that particular sense we cannot use this particular technique of solving the problem, right? Although the space complexity is order 1, but we know that we are compromising with the relative position. But if you want to preserve the relative position, you cannot go with this approach, you have to come out with something else. So we shall discuss them in the following videos. So I hope this video was helpful and intuitive. Please put your doubts if any in the comment section, and like, share and subscribe. So let us just quickly compile this particular code also and see how it is working. So yeah, you can see this particular code is also working fine, where the negative numbers are preceding the positive numbers and the relative position has changed. Fine. So yeah, that's all from my side. I hope this video was helpful. Please put your doubts if any in the comment section, and like, share and subscribe. Thank you.